Our topic for today's video is triple integrals. So let's start with the definition. A triple integration is basically a way to integrate functions which are in respect to three variables, like f of x, y, and z. And this function could be something like that. In the past, we know how to integrate a function of one variable. For example, let's take f of x equals to x. So basically the integration of this function is f of x dx with respect to the variable x will be x dx. And this will give us x squared over 2 plus a constant c. And we used integration to calculate all sort of stuff like an area under a function. Now let's take an example for triple integration. Okay, this example is asking us to find the volume bounded by this region right here. So basically we have to find the triple integration of this function right here. So our solution will be something like this. dz dy dx. So the solution is with respect to three variables. So now what we have to do is we have to define what are the limits for this integration. As we can see, the question states that the region is bounded by x equals to 0, y equals to 0, and z equals to 0. So basically, if we try to draw this function, x equals to 0 is basically the y-axis. And y is equal to 0 is basically the x-axis. And z is equal to 0 is the entire region right here. Because everywhere we go here on the xy plane is basically the value of z is 0. So when we extend our drawing to 3D, this will be a plane. And this will also be a plane. And this is the third plane. So basically we found the initial limits. So our initial limits will be something like this. Now we have to find our final limits. As stated in the question, the region is bounded by x plus y plus z is equal to 1. Now, to understand what this function looks like, we can try to look at it in a two-dimensional way. So what we can do is making z equal to 0. That way our drawing will be only in the x and y plane. So our x and y plus 0 will be equal to 1. So x plus y is equal to 1. Now this function is familiar. This is the function of a line, which we may know it as y equals mx plus c. So now if we standardize our function, it will be something like y equals negative x plus 1. So 1 is the elevation, y elevation. So our point will be, first point will be here, minus 1x. So the slope is going to be minus 1. So our line will be something like this. This is the point 0, 1. This is the point 1, 0. Okay, so now let's move on to the xz plane, which is where y will be equal to 0. So x plus z is equal to 1. And the same as the function above, this will be z. Our line will be something like this. So now basically what we know is that this function is a straight line in the three planes that we have, which is the plane xy, the plane xz, and the plane yz. So connecting these functions together will give us something like this. Something like a triangle. Now let's write our limits. So dz, dy, dx. We'll start with dz first. Basically the first value of z is 0. And the second value is a variable. So it could be written as z is equal to 1 minus x minus y. That means z could range anywhere from 0 to this triangle right here. Now let's do the limits for dy, which is y ranges from 0 to minus x plus 1, as we saw in the drawing. And x ranges from 0 to 1, as this drawing demonstrates. X ranges from 0 to 1, and y ranges from 0 to this line right here. Could be here, could be here, could be anywhere. So we just write it as variable y equals minus x plus 1. So that's how we write the integration plus the limits. Then we solve to get the final answer, which is the volume.